right, folks. Thanks for coming out. This is day 2 operations of Helm charts. I'm Dex. I work at Replicated. We're quietly powering the world's best enterprise software. We have a lot of hoodies downstairs. If you guys didn't get a hoodie yet, grab a hoodie. Grant's got a few. So a little bit about me. I'm not a Kubernetes core contributor. I've been around on a couple issues, helping on GitHub and Slack, but my biggest contribution to the Kubernetes community so far is this really silly meme. I don't know. Cool. Let's talk about charts. There's no WordPress chart in this talk, but there could be. Cool. So today I'm going to try to convince you all that Kubernetes is not, as has been purported, configuration as code. Why this matters. How you all can leverage it as maintainers and as chart consumers, and why that's great for Helm users, great for maintainers, great for Kubernetes in general. Cool, so configuration is code. Before we get into that, we kind of want to talk about like different ways to ship code. How many chart maintainers do we have in the audience today? All right, okay. Any cluster operators here? Anyone running Helm users? Awesome. Leave your hand up if you're running Helm charts in production. Hey, all right. It's good tech. Helm maintainers? You guys rock. Awesome. Cool. So first question, of course, is where I'm going is whose code are we talking about here, and where is it going? You know, there's actually like 4 ways that you can be shipping. Now, if you're an operator or a Helm user, chances are most of what you're working on is to ship your own code to your own servers. So you're probably, in relation to the other possible combinations, you're like up here, like most of the time. But if you use any of this stuff, or hundreds of other charts, you're probably in the bottom row as well, where you're deploying someone else's code to your own servers. And then if you're a chart maintainer, you're over here. And if you're building a package manager or a pass or a marketplace, you're kind of like down in this other corner. That's Helm maintainers, So in either case, the things we care about today are kind of these first 3. We got first party, and then we've got, the chart maintainer we're going to refer to as the OTS maintainer, the off-the-shelf software maintainer. And then if you're consuming charts, you're kind of the OTS consumer. So why are we making this distinction? Why determine the difference between OTS and first party? Bring us a little bit back to the idea of configuration as code. And Grant went into this a little bit. We're going to go a little bit deeper on kind of the details and kind of how to actually do it. First party, you have limited deployment environments. You have direct access to the source configuration. And you probably have direct access to the application experts. Staging and dev environments, in a lot of cases, if you're doing a full stack thing, you are the expert. So the consequences are that it's easy to change, and there's fewer changes needed because there's fewer environments. Third party is kind of the opposite. Infinite deployment environments, right? How many places are they running Postgres in production? Like I wouldn't even try to count that. And then you have limited control over the source. So you got to make a lot of changes, and it's harder to change. I got to go get permission from a stranger to update what's being shipped. So if you remember this picture from a long time ago, the DevOps wall, we knocked it down, we sprinkled some DevOps on it, now we're all working together. And so this is a lot harder for off-the-shelf stuff though. This is a lot harder for third-party stuff. Even though you may be doing this over here, there's still a wall over here when you want to use somebody else's code. And this problem kind of predates Kubernetes. We look at tools like Puppet, Salt, Chef, Ansible. We've had these tools, 2013, Kubernetes and Docker, and yeah, I know some of these are configuration managers. Kubernetes is really more of a scheduler. But they're all ways to get code up and running, first party or third party. And if you ever pulled down a Chef recipe, made a bunch of changes to it to get it working in your stack, you know what I'm talking about. This predates Kubernetes, but by nature, what I'm hoping to demonstrate is that Kubernetes is equipped to solve this problem a lot better than its predecessors. So what does this problem look like in Kubernetes? I'm not going to go super deep here because I think Grant and Mark gave a really good kind of overview of how this looks, but essentially Kubernetes has its own wall, and it's this kind of application versus runtime config wall. So on the app side, you have environment variables, config maps, image tags, pull policies, the thing that the app maintainer really knows about and is like prepared to kind of execute against. And then on the other side, you have kind of the things that would be owned by the cluster operator, things like ingress, pod security, context, HTTP proxies, all this kind of other runtime stuff. And we can kind of see these fields in a real life object. I'm omitting a couple things because match labels just makes it scroll all the way off the page. But the thing is that the runtime and the app config are kind of mixed together. So you can kind of see like we have the app config in green, so things like where do the secrets come from, what ports are exposed on these containers, and then the runtime side of things like, oh, I want 3 replicas and I need to proxy out through this tunnel. And even in the image field, you can kind of see that these two concerns are mixed together in a single YAML field, where the tag of the container that's actually going to work in a version of a kind of a chart would be kind of on one side, and then the actual repo you want to pull from might be on the other side. So these are all mixed together, and app config, again, finite configurations. The app maintainer knows all the possible combinations, and it's like easy to template. It's perfect for something like Helm. The runtime side, you've got infinite options, you've got CRDs, you've got infrastructure. It's independent of the application, and it's really like the cluster operator concerns. So you got these two things. There's this fun little parallel between app and runtime and kind of first party and third party in terms of like the limits on the number of environments and all of that. We'll get a little bit deeper into this, but the consequence of this, and we talked about this a lot yesterday, was maintaining an OSS chart means accepting a lot of changes to add configurability. So you look at like the Prometheus chart, 70% of the commits are make this one field configurable. And so as an operator, customizing a third party chart, it's slow. You got to go through a process because it's not your code, and it adds complexity. 1,000 lines of values YAML means everyone needs to learn this before they can install it. And most of the time the defaults are good, but even when you do want to change something, you got to kind of grok the whole thing. So how can I get the speed and simplicity of first party for charts I don't own? So you got two options. You can fork the chart. So we can look at this base chart where there's one value, the color blue, sets an environment variable. So we could fork this, we can add replicas to it, and then we can kind of have our runtime and our app config combined. Otherwise, you can, and then you template this out and it all works. Otherwise, you can template it out and then change it. So take the chart, don't modify it, template it out, get your color in, and then just modify the YAML at the end and add the replicas. Neither of these options are great. You get customizability, but you kind of become the owner. And this makes day 2 really hard. I want to pause here because we have said the word day 2 a bunch of times so far and haven't really defined it. So in my mind, and I'm sure there's like extensions to this, but day 2 is kind of all the things that you would do when you deploy your own application. Regular updates, monitoring, alerting, logging, canary deploys, security scanning, all this stuff. When you ship your own first-party code, you want to be able to do this stuff when you ship other people's code too. Kind of falls into 2 categories here. So like there's the observability side, which is kind of like on like more about customizing the manifest, but the deployment side and doing regular updates and continuous delivery is really like what we want to focus on today. So like you can think of your workflow as something like, you're writing some code or you're writing some YAML, you commit it, there's a review, maybe there's some pre-commit steps, you merge it in, there's an automated CI process, and then that's going to push Docker images and it's going to push YAML out to the cluster. These concerns kind of sit to the right side of this whole diagram. And so in other words, like day 2 again is like leverage the same process I use for my own code when I run something else. And to do regular updates in CD and monitoring and log aggregation, you kind of need a few things. You need like deployment flexibility, you need deep customization, and then you also need like full transparency. You need to be able to see what's actually happening. So when you do fork charts, you don't quite get all of those things. So it makes it really hard to update because now that you've forked this to add the things you need, whether you templated it or forked it directly, you still own the whole thing. And when the chart maintainer ships an update, you got to go manually merge that all in, which leads to a fun game I like to call Choose Your Merge Conflict. So you could fork the chart, and then you could resolve this merge conflict. Or you could template and modify, and you could resolve this merge conflict. Now, you can argue that this one's a little bit nicer, but it's never fun. And in the end of the day, you end up, instead of owning a couple different values files, you own all these kind of forked charts on top of that. And because it's a manual process, it probably doesn't get updated that often, which is scary because you need security, you need features, you need fixes. So the question is, like, how do I get better at this? And the answer is, you got to embrace the wall. You got this wall, you got these two classes of config, they're all mixed together. Those of you who've been following the debate, and there's a lot of talk of overlay and templating and all these different options. Like the thing that like we want to like talk about today, the solution that we're proposing is something like Helm plus customize. We've all heard this a couple times. Declarative configuration for Kubernetes. It's all based on Brian Grant's white paper, who is the Omega symbol. You've seen him floating around on probably GitHub issues and maybe Twitter. It goes deep into the difference between templating and patching and kind of why he thinks that patching is kind of the better way to do this. So I don't fully buy in because obviously like templating is necessary, and the YTT talk actually, if any of you guys caught that, was really great. So if you missed that, go watch the video. It's like a really good breakdown of all the differences. Anyways, template-free configuration means there's actually no code. And this is a lot more structured than things like Chef, where, okay, that looks like I could put that in a JSON object, but then you have variable references and for loops, and it gets really imperative. You can do the same thing for Ansible, like good, it's declarative, I have the state that I want, and I put it in a list, and it works. And then you're suddenly like templating desired state operations over like a double nested for loop, and it's, I don't know. It turns out that what we thought was YAML was actually just code pretending to be YAML. So Helm doesn't quite solve this either. It doesn't give you full access to the Kubernetes API, like by design, I think. You don't want people, you want to give people a private, public variables that they can tweak and kind of package it in a way that is approachable. There's still loops, there's still some control flow. If you really want direct access to the Kubernetes API with Helm, you can do this whole to-YAML thing, which at this point you've kind of like reinvented like Lisp writer macros for your infrastructure code. So how can customize help? The answer that we're going to throw up is patch don't fork. So we have our app config, our runtime config. If y'all are familiar with customize, we'll kind of run through a really quick example. So the chart contains the app config. We template it out, and then we write a small patch file, strategic merge, and you can build these together. So you have your things mixed together. They're stored separately, built into kubecontrol, so you can do kubecontrol customize. And so you have your template and your patch. You can extend your patch if, say, we want to update the image pull policy or something. And even though Kubernetes consumes all these types in a single object, like we can store them all separately. And this scales really nicely to a real app with actual like multiple manifests. You have your base, which is all the application side, and your overlay, which would be all the patches. And even though like the chart maintainer didn't make this configurable, I can scale this to multiple environments. Like writing a minimal amount of YAML to make the tweaks that I need. So staging replicas 3, production replicas 10. So what does this have to do with day 2 operations? Kind of the difference between, it gets back into the difference between templating and patching. You know, the user can periodically rebase their base is straight out of the white paper there. And it's kind of like, this is the most important innovation of Customize, is you can pull down the latest and you're never resolving git merge conflicts. Because there's no templates, because there's no code, because there's no control flow, we can just do this really easy, like structured object merge. It's still a merge, there's still room for conflicts, but we find that in 90% of cases, you can just pull the new one and you never ever get stuck with something like this. Another bonus is like customize emits plain YAML, which means you get grokkable diffs. And then, so yeah, that's it. Patch don't fork. It's easy to customize, it's easy to update. It's a lot of steps that we went through. So we've kind of like built a tool that we'd like to share with y'all for how to really operationalize this. So replicated COTS stands for Kubernetes off-the-shelf software. It's this, if you're familiar with replicated ship, it's kind of the spiritual successor to that project. It's really optimized for managing Helm charts. There's no more forking charts. It streamlines the advanced side of the configuration with customize. It plugs into your workflow. You can do GitOps and all that fun stuff. So if you want to do this, you want to merge, and you want to kind of have your chart maintainers on one side, cluster operators own the advanced config, the patch moves along with the updates, and instead of owning fork charts, you just own some patches. COTS is built on this idea of midstreams and downstreams. So customize is kind of infinitely recursive. You can have as many layers here as you want. But this is kind of the formula we found works for most folks, where the upstream is a chart owned by a maintainer, and the midstream is essentially like our organization-wide like config for this object. So say we're going to run 20 different Redises, but they're all going to have the same kind of basic parameters in the base set. Environment variables, memory limits, however we're going to do it. And then the downstreams are your actual like deployment environment. So you might have prod EU West, prod US East, maybe a staging environment. And so we can look at this basic workflow. And the idea here is that COTS, formerly SHIP, is going to plug in at the code review stage and let you kind of like pipe all of the changes coming from the Helm Charts Hub or from Monocular into your core first-party workflow. So you can get, essentially it's going to make pull requests as things change. So, new image tag, new environment variable, turned off the host network, great, I can merge this. There's another thing that it can do where it like pipes Docker images as well. We're not going to go too deep into that. So to see how all this works, we're going to do like a custom install with a community chart. I'm going to assume I'm using some sort of GitOps. There's a lot going on in this picture, so to simplify it, we made this really beautiful diagram in Google Slides. Essentially, you have some stuff, things happen, it gets into a repo, and once things are committed to the repo, then it's going to get piped into the cluster. And so COTS is going to own kind of just one side of this. The big goal is like it's going to help you get the right things into your repo, and you bring your own process for the right side of this. We're going to install an app called BetterDB. This is a very small app. And super simple. It's not actually a database. It's got small values file. And so we're going to have the upstream, which is the chart. We're going to have a midstream, which is kind of our core config. And then we'll have two downstreams. We'll have production and staging. And COTS is going to help us, again, get the right thing in the right repo as soon as it's released. And like getting back to day 2 operations, like as things are pushed into the repo, this is where you can do things like CVE scanning, integration tests, policy enforcement, managing Docker images, and then even going further to the right of doing automated monitoring. Because you own the right side, you can do all your canaries and log aggregation and kind of all the normal ways that you would ship your own code that you're managing. So let's pop into a quick demo, and we'll see what we can do. So let me go. And somewhere is the browser. Great. Cool. So I have the BetterDB chart here. This is just community chart. I have my GitOps deploy repo. So this is that repo from the diagram, which is like when things get merged into specific branches of this, they'll go out to specific clusters. So I have a staging branch, I have a production branch, and the assumption is that there's some process that gets that live in those specific downstreams. So we're gonna use a tool. This is a hosted version of this that you can log into with GitHub. It's public right now. It's also open source, or will be open source very soon, I think. There's a version of it you can run on-prem in your own cluster. It has other auth methods other than GitHub. You can just log in with email, things like that. But essentially, it's a multi-app management dashboard. And so you can have a bunch of different Helm charts managed in this way. So to kick this off, I'm just going to install a new application here. So I'll grab the URL from GitHub. There's a bunch of different URL formats that are supported here. You can do Helm URLs and all of that. And I'll initialize this. This is going to give us those 2 steps, is take the Helm values, put in our custom stuff for that, and then a second step where we can put in our advanced configuration. So let me just do a couple changes here. Y'all see that? Do I need to make that bigger? So we'll change the replica count to 2. And then we'll change the service type to load balancer. Let's say I'm running in a cloud provider. So the basic options get configured via the Helm values, and then it's going to template everything out and give me the option to add additional customizations on top. And in this case, the patch we're going to add on is going to be some custom secret management via a Vault init container. So it's going to, we manage secrets in our own way. We don't want to use environment variables. And so what we're going to do is we're going to add an init container that's going to copy secrets out of Vault and drop them into where they need to be. There's kind of an editor here that can help you build patches out. What I'm going to do is actually I just have this patch somewhere that I'm going to just grab it. Cool. So I'm going to tap here. I'm actually just going to paste this in here. I can save this. I can see the diff of what's been changed here. So this is just adding an init container and then adding some volume mounts to the already original container. We can save through this. And then the option here is I can, excuse me, this is going to run through. I can just download the YAML that is the result of this, that is the application. But what we're going to do instead is we're going to cause this to create a pull request into our GitOps repo. So I can add deployment to a cluster. I've already got a couple set up here. I've got a staging GitOps branch. We'll put this into a folder called BetterDB, and then we can add that cluster. Now what's going to happen here is we have the option to add additional customization for the downstream. So in this case, the edit I'm going to make here is essentially just modifying the Vault kind of URL that we're going to use. So this is our staging environment. So we'll pop through here, and again, this kind of shows you the more interactive side of this. So I can come in and say, vault staging.somebigco.com. Cool. So I've got my midstream, which is my kind of like standard configuration, and then I've done environment specific tweaks at the downstream layer. Cool. And so what this is going to do is going to create a PR into my staging repo, and I can come here and I can review it. You can see all the YAML being merged in. I'm going to pull this in, and essentially that's going to, in a sec, should show that we've updated the version here. We can do the same thing for our production. Essentially, in this repo, I've got a production branch and a staging branch. But what I'm going to do actually is, for a sec, I'm going to take off my cluster operator hat, and I'm going to put on my Helm chart maintainer hat, and we're going to ship an update to this chart. So if we go into the BetterDB chart, let's assume I'm the CTO of BetterDB. I see there's a PR from a contributor here, and they're bumping the image tag, which is great. And they're adding a parameter for the log level. And I say, great, we should let people set the log level when this thing is running. So I'll come through here, and I'll merge this in. So now the Helm chart has been updated behind the scenes. Maybe it happened in a different time zone and I was asleep as the cluster operator. So I can come here. This is always polling in the background. Just for the sake of the demo, I'm going to manually check for updates. And this is going to detect that a new version of the chart is available. And then it's going to make a pull request into the repo that I initially set up. And it's coming. And okay, great. So we can pop back over here and into my GitOps deploy repo. We should see shortly. Of course, you do this 5 times and then we do the live demo and it doesn't quite make it. Okay, cool. So we have the upstream version is 0.30. And if we refresh here, we should see, okay, cool. So we got a PR from the admin dashboard, and you can see just the changes to the Kubernetes YAML that are going to happen. So environment, log level, default to info, and we got the new image tag. So as the kind of cluster admin, I can also review this. If this was a full-on day 2 operated stack, there you can have all of your PR checks and integration tests and vulnerability scanning and all of that happening at this stage. So I can go ahead and merge this in, and then if I come back to the dashboard, we're up to date. So, and then you can do that across multiple environments. So you have internal processes that happen before and after deploy. You can go to staging but not merge the production one. It's fully auditable. You get good rollbacks, all of that. You don't need me to preach the virtues of GitOps. So that's essentially the tool. It's COTS ADM. It's open source application. Kubernetes. It's got a Helm chart install. It's multi-apps. It does GitOps. It's got lets you have multiple downstreams. All that stuff about doing pre-flight checks against clusters before installing apps into them. It's got kind of sophisticated app maintainer defined troubleshooting tools in there. And so in general, like as an operator, you get to own less YAML, you get to use your own process, you can change whatever you want, and you get to see exactly what's going on. As a maintainer, you write mostly YAML and fewer templates, and you only template your app config. Nobody will fork your chart anymore. This makes Helm even more flexible than it already is, and it enables kind of first-time and advanced users to customize exactly what they want. So next steps, you can go check out the COTS project. You can do a COTS pull to do this locally. You can do COTS install to work with that admin console. The Helm install is coming soon. We have a plugin called Outdated Kube Control plugin, so you can scan your cluster for images that are out of date compared to the Docker registry. Similar with Unfork that Mark demoed yesterday. You can find us in the ship channel at Kubernetes Slack, probably soon to be renamed to COTS. Shipping 1.0s of projects is hard. And last of all, embrace the wall. It's not going anywhere. Thanks, everybody. That's day 2 operations at Helm charts. How are we doing on time? No time for questions, huh? We'll be down at the booth. Come grab a hoodie. I'd love to chat more about this. Oh, Grant's got hoodies right there. Save yourself a trip down the stairs.